The sky over America has been on fire, not metaphorically, literally. Since March 10th, 2026, the United States has been struck by more large fireballs than any single month in 15 years of recorded history. And it is not even close. The rate is 4.5 standard deviations above normal, a number statisticians reserve for events that simply should not happen. 79% of them shook the ground when they landed. 3 separate rocks, recovered from 3 separate impacts across 2 continents, all carry the same rare mineral fingerprint, the same one. Now here is what the news will not tell you. In debris stream physics, the small fragments always arrive first, spread out ahead of whatever created them. What we are seeing right now may be the leading edge. Stay with me until the end, because what comes after the leading edge is the part that actually matters, and that no one is talking about yet. Hit subscribe and stay close, because this one is still developing. The impacts are still being recorded. The fragment data is still being processed. When the full analysis lands, this channel is where you will hear it first. You will want to be here for that. Now, let's get into it. Something changed in the sky on March 10th, 2026, and the data noticed before anyone else did. Not the cameras, not the journalists, not the government press releases. The data. Specifically, the Fireball database maintained by the American Meteor Society, which has been running continuously since 2005 and reached its full operational maturity somewhere around 2016 to 2018. This is not a new system with rookie calibration errors. This is a mature, well-documented, rigorously maintained archive. And in March of 2026, it started producing numbers that the people reading it had never seen before. Let me put this in perspective, because the numbers matter and they deserve a slow read. In a typical year, the first quarter of the calendar, January through March, produces somewhere between 1,100 and 1,400 total fireball events in the database. That range has been stable for years. It's the kind of stable that scientists love because it gives you a reliable baseline to measure against. In the first quarter of 2026, the AMS recorded 2,046 total events. That is high, but here's the thing. It's only marginally above the 2,037 events recorded in the same window in 2022. So on the surface, if you just look at the raw count, you might shrug and move on. You would be making a serious mistake. Because the story is not in the total count. The story is in what kind of fireballs are being counted. Here's where it gets strange. At the lowest threshold, fireballs seen by fewer than 50 people, 2026 looks almost identical to recent years. Normal, unremarkable, nothing to write home about. But as you raise the threshold, something startling happens. At 50 or more witness reports per event, 2026 has produced 38 events. The historical average for that same window is 18. You just more than doubled it. At 100 or more reports per event, 2026 logged 14 events against a baseline average of 7. Doubled again. And then you hit March alone, which produced 5 separate fireball events exceeding 200 witness reports. The previous record for an entire March, going all the way back to 2011, was 0. March 2026 did it 5 times. The signal gets stronger as the threshold rises. That sentence is important. That is the hallmark of a genuine physical change in the incoming material, not a reporting artifact. Not more cameras, not AI tools routing witnesses to the AMS website faster. Not a viral moment making everyone look up. Those things would inflate all the numbers roughly equally. What you see here is the upper tail of the distribution breaking away from the rest. The small stuff is unchanged. The large stuff is surging. Something is specifically different about the large, bright, energetic end of the equation. And then you get to witness counts per event. and a new dimension of strange opens up. The March 8th event over Western Europe, a slow-moving 6-second fireball visible across France, Germany, Switzerland, Belgium, and the Netherlands, was reported by 3,229 people. 3,000 for a single meteor event. That is a number that doesn't exist in the prior record. But even setting that extraordinary outlier aside, the remaining events in March 2026 averaged around 67 witness reports each. The historical norm is closer to half that. Mike Hankey, the AMS researcher who led the analysis of this period, described it plainly. Almost half of all March 2026 events with 10 or more reports were seen by 50 or more people. The distribution did not broaden. It shifted upward. You know what that means physically? It means the objects are bigger, brighter, and more capable of reaching more eyes across wider geography. Bigger and brighter means more energy, and more energy means we need to start asking where that energy is coming from. Which brings us to sonic booms. Because 30 of the 38 events that crossed the 50 report threshold in the first quarter of 2026 produced audible booms. That is 79%. Let that sit for a moment. A sonic boom from a meteor is not a given. It requires an object large enough and dense enough to survive serious atmospheric entry, to push through the upper atmosphere without simply burning out in a pretty streak of light 100 kilometers above your head. A sonic boom means the object went far down. A sonic boom means the object was substantial. And 79% of the large events doing it is not a number you can explain away with camera upgrades. A chatbot cannot generate an atmospheric shockwave. An AI reporting tool cannot trigger NOAA's GOES lightning mapper satellite. But the Ohio fireball on March 17th did exactly that. A 7-ton, roughly 6-foot asteroid that burned so brightly, a weather satellite captured the flash from orbit. A fragment from the Texas fireball on March 21st punched through the roof of a house in Houston and ricocheted around a bedroom. These are not atmospheric ghosts. These are physical objects with mass and momentum, and a very specific message encoded in their behavior. The message is this: the dataset has changed shape. Not just the numbers inside it, the shape of the distribution itself has shifted. The small end is normal. The large end is not. Something different is arriving in the upper size range. And whatever you think might explain that, there is one thing you cannot do. You cannot explain it with more people looking up. So what kind of objects are actually arriving? The AMS analysis broke down the direction these fireballs are coming from, what astronomers call the radiant, meaning the point in the sky from which an object appears to originate. And two things emerged. First, there is a meaningful concentration of events from a region of sky called the Anthelian sporadic source. The Anthelian is the region of sky directly opposite the Sun. Objects coming from this direction are not falling inward toward the Sun like most sporadic meteors. They are catching up to Earth from behind as they plunge deeper into the inner solar system. Historically, the Anthelian has always produced some fireballs. In early 2026, activity from this specific slice of sky roughly doubled. Nearly 10 major events traced back to a single 1,000 square degree patch within it. A March 9th fireball, seen by 282 people along the U.S. eastern seaboard, traced back here. 2 fireballs reported a combined 381 times over France on consecutive days, traced back here. Second, astronomers detected a meaningful spike in fireballs coming from high declination radiants, rocks traveling on steeply inclined orbits relative to the flat plane of our solar system. That is unusual. And combined with the Anthelian pattern, it starts to describe something that doesn't behave like a clean, predictable annual shower. It looks messier than that. It looks more like a cloud with structure, or a stream with lumps. Here is the question that should already be forming in your mind. If these fireballs are arriving from different directions in the sky, and they share certain physical properties, size, energy, the capacity to survive atmospheric entry, what does that tell us about where they came from? Because this is where the story stops being a statistics anomaly and starts being something closer to a mystery. And if you thought the statistics were strange, wait until you hear what the rocks themselves are made of. Every meteor shower you have ever heard of has one thing in common. Whether it's the Perseids peaking every August or the Leonids lighting up November nights, they all radiate from a single point in the sky. You trace any meteor in a shower backward along its apparent path, and all roads lead to the same origin point, the radiant. This happens because all the objects in a defined shower are traveling on essentially the same orbit, laid down by the same parent comet, intersecting Earth's path in the same predictable window every year. A shower is, in a sense, proof of order. It's the solar system showing you its filing system. Everything in its place, everything on a known schedule, everything explainable by a single source event that happened centuries or millennia ago and left a tidy trail of breadcrumbs for Earth to walk through once a year like clockwork. What is happening in 2026 does not look like a shower. Yes, there is a clustering around the Anthelian sporadic source, and that pattern is real and documented. But here's the critical distinction. This is not a defined pinhole radiant. The Anthelian is a broad region of sky, roughly the size of several hundred full moons laid side by side. Sporadic meteors from this direction appear because it is a statistically favored zone for near-Earth encounters, as objects move on prograde orbits that happen to intersect our path from behind. Not because there is a single ribbon of debris threading through space like a highway with guardrails. The Anthelian is a neighborhood, not an address. And crucially, the fireballs observed over Germany on March 8th and over Ohio on March 17th. Two of the most significant and well-documented events of this entire period did not originate from matching orbital vectors. They came from different parts of the sky on unrelated trajectories. According to AMS researcher Mike Hankey, these events are not linked to a single object or source event. The sky map does not align. There is no single radiant connecting all the dots into one clean picture. So, what does that actually mean? It means the simplest explanation: a new, coherent meteor stream neatly producing everything we are observing has been eliminated from consideration. Ruled out. Gone. What remains is something more complicated, and honestly, something more interesting. Either Earth is moving through a diffuse cloud of material with multiple clustered components spread across different orbital families, or there is a population of debris in near-Earth space that has been disrupted or scattered by gravitational interactions over a very long time, and we are currently intersecting a denser pocket of it from multiple angles simultaneously. Both possibilities carry real physical implications. Neither one is particularly reassuring when you sit with it long enough. Now let's talk about the sonic boom rate again, because it carries physical information that goes well beyond the spectacle of a bright light streaking across the sky at 2 in the morning. When an object produces a sonic boom, a genuine ground-level, window-rattling shockwave, it tells you something very specific about its composition and internal structure that no amount of visual observation alone can give you. Objects that are loosely assembled, what planetary scientists call rubble piles, which is exactly what it sounds like, a gravitationally held collection of smaller fragments that never fully consolidated into solid rock, tend to disintegrate high in the atmosphere. They encounter the first layers of thickening air at around 80 to 100 kilometers altitude, and they simply fall apart. They bloom into spectacular light shows, occasionally spectacular enough to light up an entire hemisphere of sky, and then they leave very little trace. No boom, no fragment, no rooftop damage. Just a memory and a lot of excited social media posts. Objects that are more cohesive, denser, more structurally intact, made of rock that was once part of a geologically differentiated body. Behave completely differently. They survive further down. They push through the upper atmosphere and into the stratosphere before the mechanical stress of deceleration finally overcomes their structural integrity and forces them to fracture. That fracturing releases energy explosively, and that explosion propagates outward as a shockwave at the speed of sound, traveling downward and outward across hundreds of kilometers of ground. Windows rattle, car alarms trigger. People who are asleep wake up and reach for their phones. And occasionally, as residents of one Houston neighborhood discovered on March 21st, the leading fragment punches clean through a residential roof and bounces around a bedroom like it has somewhere to be. 79% of the significant events in this window produced those ground-level shockwaves. 79. That is not the profile of a rubble pile population drifting through the inner solar system on loose, unconsolidated orbits. That is the profile of something dense, something structurally coherent, something that was once part of a body that was itself geologically differentiated before it broke apart. A body with layers, with internal structure, with a history of heat and pressure and planetary scale geological processing. The word differentiated is doing a lot of work in that sentence, and it is about to do even more. Because when researchers analyzed the fragments recovered from 3 separate events across 2 continents, they found something that the sonic boom data had already quietly predicted. And it turned out to be the most unsettling data point in this entire story. They did not find something unexpected. They found the same something 3 times in places that had absolutely no logical reason to share it. The Germany bolide on March 8th dropped recoverable material across a field near the German-French border, and the fragments were collected and sent for analysis within days. The Ohio fireball on March 17th left material scattered near Cincinnati, recovered by a team that had been tracking the event's terminal trajectory from infrasound sensor data. The Texas event on March 21st delivered its sample in the most direct way possible, directly through a residential roof in Houston, landing on a bedroom floor with enough residual heat to leave a scorch mark on the carpet. 3 events, 2 continents, completely separate entry trajectories coming from different directions in the sky, with no shared orbital geometry that any current model can connect. And all 3 fragment sets came back from the laboratory with the same rare mineralogical classification: HED achondrites, howardite, eucrit diogenite, a family of igneous meteorites with a very specific, very well understood, and very telling origin story. Let's unpack that, because it genuinely matters and the details are worth following carefully. Most meteorites you will ever read about are chondrites, primitive, undifferentiated material that has essentially not changed since the early solar system formed 4.5 billion years ago. Chondrites are the raw dough of planetary formation. They are what the solar system looked like before any of it had the time or the mass to heat up, melt down, and reorganize itself into layered structures. They are ancient, and they are everywhere, and they are scientifically fascinating, but they are also, in a sense, the default, the background noise of space rock. HED achondrites are something different entirely. They are crustal and mantle material from a body that actually went through planetary differentiation, meaning it accumulated enough mass and generated enough internal heat through radioactive decay and gravitational compression to separate into distinct layers. A metal-rich core sinking to the center, silicate mantle rock forming above it, crustal material crystallizing at the surface. This is what happens to actual planets. This is what happened to Earth. And in the asteroid belt, it happened to 4 Vesta. Vesta is the second largest object in the main asteroid belt, roughly 525 kilometers across, and one of the very few asteroids large enough and old enough to have undergone this full planetary-style geological evolution. It is essentially a protoplanet that ran out of raw material before it could finish the job of becoming something larger. And it carries the evidence of that interrupted evolution in a scar that is almost impossible to overstate. A massive impact crater at its south pole called Rhea Silvia, formed by a collision roughly 1 billion years ago, so large that it excavated material from deep within Vesta's interior and blasted it outward across the inner solar system. The objects produced by that ancient impact, the Vestoids as they are collectively called, have been spreading through near-Earth space ever since, gradually diffusing across a range of orbital paths through gravitational interactions with Jupiter and the other planets. And for hundreds of millions of years, they have been raining HED fragments onto Earth at a low, steady background rate. So finding HED chondrites in a recovered meteorite is not, by itself, a cause for alarm. It happens. Vesta is a known and prolific source of near-Earth material, and the HED family is well represented in meteorite collections worldwide. What is not normal, what has not happened before in the recorded meteorite literature in quite this way, is finding them simultaneously in the same narrow window of days, from fireballs arriving on completely unrelated trajectories from different regions of sky. These three objects are not fragments of the same rock. The orbital geometry eliminates that possibility entirely. They approached Earth from different directions. They cannot have traveled together, and yet they carry the same mineralogical fingerprint, the same parent body family, the same ancient geological history, the same billion-year-old crustal origin story written in the mineral structure of the rock itself. Same fingerprints, no shared trajectory, no common flight path, no orbital connection that any current model can draw between them. That is a contradiction the data has not resolved, and it is precisely the kind of contradiction that, in science, points towards something real waiting to be found, a structure, a population, a source that is producing this pattern and has not yet been identified. The fragments are here. Whatever sent them is not yet in the catalog. And that gap between what is arriving and what has been found is where the rest of this story lives. When the conventional explanations start failing one by one, what's left tends to look a lot like the truth. And in this case, what's left is a concept that planetary scientists have studied for decades, but that rarely makes the news: the debris stream. Here is how a debris stream works, and I want you to really follow this, because the physics of it is what makes the current situation so important. When a comet or a large asteroid travels through the inner solar system, it sheds material. Comets do this constantly. The solar wind boils off gas and dust and larger chunks as they approach the sun, and those fragments inherit orbits very close to the parent body's own path. Asteroids shed material when they collide with each other, when rotational forces cause surface material to spin off, or when tidal forces during close planetary passes rip chunks loose. Either way, the result is a trail of debris strung along a shared orbital path, like pearls on a string, but a string that gets longer and messier with every orbit. Now here is the crucial part. Not all fragments in a stream travel at exactly the same speed. Velocity differences, even tiny ones, cause the smaller, lighter fragments to drift forward over time, spreading ahead of the larger, heavier pieces. This is a fundamental consequence of orbital mechanics. Over centuries and millennia, what started as a compact cluster of debris gets sorted by size, with the smallest particles spreading furthest along the orbital path and the largest concentrations remaining further back. What this means, in practical terms, is that when Earth first begins to intersect a debris stream, it tends to encounter the smaller stuff first. The front edge of the stream is populated with the fragments that have drifted furthest ahead. The main mass, the larger objects, the denser concentrations, whatever is still gravitationally bound or traveling in the tightest cluster, arrives later. Now look at the 2026 data through that lens. The small, faint, low witness count meteors are unchanged from historical baseline. The large, energetic, sonic boom-producing fireballs have surged dramatically. The pattern says the very small material is not behaving differently, but the large material has spiked. In a classic debris stream intersection, you would not expect this. You'd expect everything to go up together if you simply flew into more material. But if you are hitting the front edge of a stream, if you are in the leading, sparse section where only the fastest traveling fragments have arrived, then the small, lightweight dust that spread furthest would still be near its background level, while the first of the larger, denser bodies that have caught up to the leading edge start making their presence known. That is a very specific and testable prediction from debris stream physics, and the 2026 data is consistent with it. The toroid complex is the most famous example of this kind of structure. The toroids are a broad, dispersed stream of material associated with Comet Encke, and potentially with a much larger progenitor body that broke apart thousands of years ago. Every few years, Earth passes through a denser swarm within the toroids, what researchers call the toroid resonant swarm, and fireball rates jump noticeably. The 2015 and 2022 toroid seasons both showed elevated fireball activity that matched this model. The mechanism is understood. It is repeatable. It is physics. But here is where 2026 departs from that comfortable template. The toroid swarm has a known parent. Comet Encke is cataloged, observed, tracked, and modeled. Its stream is mapped. We know where it is and when Earth will cross it. The structure producing the 2026 anomaly has no confirmed parent body, no named stream, no orbital model that any current catalog points to as the source. The AMS analysis identified the Anthelion region as a significant contributor and the high declination radiant cluster as a secondary component, but neither of those is a debris stream in the formal sense. They are directions in the sky, statistical neighborhoods, not named highways with known on-ramps. What makes the missing parent body so important? Think about it this way. Every effect has a cause. Every fragment that hits Earth's atmosphere broke off something. The HED achondrite signature points toward the Vesta family, toward the Vestoids, the population of asteroids derived from that ancient South Pole impact on 4 Vesta. The Vestoid family is real, it is cataloged, and there are several large members currently in near-Earth orbits. But no specific Vestoid has been identified as the source of the 2026 surge. No object has been found in the current orbital geometry that would explain both the HED mineralogy and the radiant distribution simultaneously. The fragments are arriving. The parent is absent from the record. That is not a small gap. That is a gap the size of an asteroid that should be in a catalog and isn't. And in planetary defense terms, there is almost no outcome worse than detecting the downstream effects of a large near-Earth object before you have detected the object itself. The fragments are the warning system. But a warning system only helps if you know what you're being warned about. The selective amplification of the large end of the fireball size distribution is actually the most diagnostic clue in the entire dataset. In a natural background population of sporadic meteors, the size distribution follows a well-understood power law. There are vastly more small objects than large ones, and the ratio between size categories is predictable. If you double the total incoming flux, if Earth just happens to be moving through a denser region of the overall sporadic background, you would expect that power law to hold. Everything would roughly double together. But that is not what is happening. The small stuff is flat. The large stuff is surging. That means the mass distribution of the incoming population has changed. The incoming objects are not just more numerous at the large end. They represent a different population, one that is disproportionately skewed toward higher mass. In a debris stream model, this is exactly what you'd expect if Earth was intersecting a segment of the stream where a genuine concentration of larger fragments had accumulated. It's not just more material, it's different material, heavier, denser, and arriving in a cluster. Picture a highway in a rainstorm where all the drops are normal, small raindrops, and then, suddenly, golf balls start falling. The rain hasn't changed, but the golf balls are new, and they're coming from somewhere specific. That somewhere hasn't been identified, and that is the problem. Science works by a process of elimination. You build every plausible explanation you can think of, and then you hold each one against the data until it either survives or collapses. So let's do that here, methodically, and see what's left standing when the dust settles. The first and most popular explanation offered in the early news coverage, to the extent there was any serious news coverage, was the surveillance expansion hypothesis. More cameras, more dash cams, doorbell cameras, all-sky meteor monitors, and fireball reporting apps creating an illusion of more events, when what's really happening is just better documentation. This is a legitimate concern in any anomaly detection scenario involving observational systems. The AMS takes it seriously, but it fails against the 2026 data for a specific reason. Camera networks capture everything proportionally. If expanded surveillance is inflating your fireball count, it inflates the count at all brightness levels. Faint events go up, medium events go up, bright events go up, together, roughly in the same ratio. What you do not get is a scenario where faint events are flat and bright events have tripled. The surveillance hypothesis predicts uniform inflation. The data shows selective amplification. These are mutually exclusive outcomes. Camera networks did not do this. The second explanation is seasonal variation. Some periods of the year are simply more active than others as Earth crosses through different regions of the sporadic background. March does have some elevated activity due to the geometry of Earth's orbit at that time of year. But again, this fails against the data. Seasonal variation is gradual, predictable, and produces smooth changes across the distribution. What happened in March 2026 was abrupt. The spike arrived clustered in the second half of the month, following March 10th in particular. Seasonal drift does not produce a sudden jump in high significance events within a 2-week window. The calendar doesn't work that way. The third explanation is reporting bias specific to the AMS network. The idea that the US heavy concentration of AMS camera stations and volunteer observers creates a geographic distortion that makes American skies look more active than they really are. This one is interesting, and it deserves respect as a methodological consideration. The AMS network is genuinely denser over the continental United States than over most other regions of the planet. But here's the contradiction. If reporting bias were driving the anomaly, you would expect the elevation to track the camera density, not the fireball energy. High-energy events, the ones that light up multiple states, trigger satellite detections, produce sonic booms across hundreds of kilometers, are not dependent on a single observer station being in the right place. The Ohio fireball was detected by infrasound sensors, weather satellites, and eyewitnesses across 6 states. The Germany event gathered over 3,000 reports across 5 countries. These events would not be invisible without the AMS network. The reporting bias argument handles the marginal events. It does not explain the outliers. The fourth alternative worth addressing is the one that gets floated quietly in certain corners of government-adjacent aerospace circles: military activity, hypersonic test vehicles, high-altitude intercept tests, orbital re-entry events. The speeds involved immediately rule this out. The fireballs in question are traveling at entry velocities in the range of tens of kilometers per second. The March 9th bolide was estimated at around 30 kilometers per second at atmospheric entry. Nothing humans have launched returns from orbit at those velocities. The fastest hypersonic vehicles, tested as of 2026, top out around 3 kilometers per second. And military debris re-entry leaves a very specific spectroscopic signature, refined metals, manufactured alloys, that is completely absent from the HED achondrite fragments recovered on the ground. The rocks are ancient solar system material. They are not engineered objects. Now let's discuss the one explanation that captured significant public attention for a different reason: the interstellar connection. In 2023, astronomers identified an object called 3I Stroke Atlas, a fast-moving body exhibiting characteristics consistent with an interstellar origin, meaning it appeared to be passing through our solar system from outside rather than orbiting the Sun in a closed path. Interstellar objects are genuinely real. 1I Stroke Oumuamua in 2017 and 2I Stroke Borisov in 2019 established that the solar system does receive visitors from other stellar systems. 3I Stroke Atlas added to that confirmed category. And when the 2026 fireball anomaly emerged, a natural speculative leap appeared in online science communities and fringe research circles almost immediately. Was Earth crossing the orbital path previously traveled by 3I Stroke Atlas? Was there interstellar material, dust, fragments, debris shed during the object's passage through the inner solar system, now intersecting Earth's orbit? It is a genuinely interesting hypothesis, and it is important to give it a fair hearing rather than dismissing it because it sounds dramatic. Here's what makes it interesting: the timing. If 3I Stroke Atlas passed through the inner solar system on a specific trajectory, there is a window, roughly 2 to 3 years later, where Earth's orbit could theoretically intersect regions of space the object passed through. The physics is plausible in principle, and the increased energy profile of the 2026 events, the high velocity implied by deep atmospheric penetration, is not inconsistent with material on a hyperbolic or near hyperbolic trajectory. Here is what makes it incomplete: the mineral signatures. HED achondrites are definitively solar system material. They are the geochemical product of a body that differentiated under solar system conditions, using solar abundance elements in a gravitational and thermal environment consistent with formation at 1 to 3 astronomical units from our Sun. If you found fragments with interstellar provenance on the ground, they would look fundamentally different: anomalous isotope ratios, unusual elemental abundances, mineral phases that don't match any known solar system rock type. The Ohio, Texas, and Germany fragments don't show any of that. They are native solar system material. They came from an asteroid that formed here. So either the interstellar hypothesis is simply wrong, or the HED achondrites are coincidental, and the interstellar material has simply not been recovered yet. The first option is more parsimonious. The second can't be ruled out entirely. Neither conclusion is fully satisfying, which is exactly the kind of epistemic discomfort that drives people towards simpler, more emotionally complete narratives. And that is the opening through which the internet walked. The viral alternative theories are worth documenting, not because they have evidential merit, but because they reveal something real about how human minds respond to unexplained patterns. Within 72 hours of the Houston rooftop impact, several large social media accounts were circulating a claim that the fireball activity represented intercepted probes, objects that had been shot down or deliberately redirected by some unknown agency. Within a week, amateur videos analyzing the flight paths of various events were racking up millions of views, claiming that the trajectories showed impossibly consistent geometry that could only be artificial. One account with over 2 million followers posted a thread alleging that a specific geologist associated with the fragment analysis had gone missing after publishing preliminary results. The geologist in question posted a perfectly ordinary photograph from a conference in Vienna 4 days later. None of this stopped the narrative. This is not new behavior. In 1561, a mass sighting of unusual aerial phenomena over Nuremberg, Germany, likely an unusual atmospheric optical event, was interpreted by witnesses as a battle between celestial armies. The engravings made at the time show what people saw: metallic spheres, spinning disks, crosses. What they were actually seeing remains debated by historians and atmospheric scientists. But what they experienced was undeniable: a strange pattern in the sky, no official explanation, and a cultural framework ready to absorb the mystery into its own language. 2026 has better cameras and faster internet. The interpretive machinery operates on the same principles. The deeper psychological reality is this: humans are extraordinarily good pattern recognizers. So good, in fact, that we find patterns in noise. When a genuine anomaly appears in data, a real, statistically significant, unexplained deviation from the expected, the pattern recognition system that evolved to keep us alive does not distinguish between a real pattern and an inferred one. It fills the gap. And the gap here is wide enough to drive entire cosmologies through. There is no named parent body. There is no identified stream. There is no confirmed causal structure. Into that absence, every available narrative rushes like air into a vacuum. The data is real. The interpretation is the battleground. Here is the part where I have to be careful, because what I'm about to describe is a hypothesis, a pattern-based inference from established physics, not a confirmed prediction. It is important that you hold it that way, but it is also important that you hear it, because the physics is not speculative. The physics is textbook. Only the application of that physics to the current situation involves uncertainty. Debris streams are not uniform. They are not evenly distributed ribbons of material spread smoothly along an orbital path like frosting on a cake. They are lumpy, structured, heterogeneous, the product of complex gravitational interactions over very long timescales. Jupiter's gravity, in particular, acts as a sculptor of debris stream architecture, trapping material in specific resonant orbital periods and creating concentrations called swarms. The Torrid Resonant Swarm is the best documented example, a cluster of larger objects embedded within the broader Torrid stream that Earth encounters only during specific orbital alignments. When Earth is inside the swarm, fireball rates jump. When Earth exits, they return to background. The swarm is not hypothetical. It has been observed, modeled, and confirmed across multiple apparitions. Now apply the physics of debris stream internal structure to the leading edge hypothesis. If what Earth is currently intersecting is the front portion of a structured stream, the region where the fastest moving, furthest drifted fragments have arrived ahead of the main concentration, then the current activity represents only part of what the stream contains. The leading edge, by definition, is less dense than the core. The largest fragments, the ones too heavy to drift far ahead, even over centuries of orbital mechanics, remain further back in the stream, closer to whatever source event generated the debris in the first place. A leading edge intersection would produce exactly what we are observing: a statistical elevation at the large end of the size distribution, reflecting the first arrivals of more substantial material, while the overall flux remains moderate, not a full bombardment. A preview. The question of whether a denser, more massive portion of the stream is behind the current activity cannot be answered with the data currently available. The orbital structure of the source population has not been mapped. There is no model. There is no confirmed stream name or parent body to run calculations against. What exists is a pattern in the impact record, a mineral signature pointing toward the Vestoid family, a radiant distribution centered on the Anthelion source, and the fundamental physics of how debris streams propagate through time. Those pieces are consistent with a leading edge scenario. They do not prove it. Consistency is not proof. But in the absence of a better fitting model, consistency is the best working hypothesis available. What makes the institutional silence around this so remarkable is not that agencies are hiding something. I want to be clear about that. It is that the near-Earth debris environment at the small to medium object scale is genuinely undermapped. The major planetary defense programs, NASA's Center for Near-Earth Object Studies, the European Space Agency's Space Situational Awareness Program, the Catalina Sky Survey, the Panoramic Survey Telescope and Rapid Response System, known as PAN-STARRS. These systems are excellent at detecting and tracking large objects, things tens of meters across and above. They have cataloged over 35,000 near-Earth objects and growing. But the population of objects in the 1 to 10 meter range, large enough to produce significant fireballs, occasionally large enough to deliver roof-penetrating fragments, small enough to enter the atmosphere before anyone knows they're coming, that population is not fully inventoried. It cannot be, with current telescope technology and sky coverage. Objects in that size range are simply too small and too numerous to catalog comprehensively. We detect them when they hit us, and we understand the stream that produced them only after we've been hit enough times to reconstruct its properties from the impact record. This is a fundamental asymmetry in how planetary defense actually works. We map consequences faster than we map causes. We know what hit us before we know what's still coming. And in the case of a structured debris stream with an unidentified parent body, the impact record is the only map we have. The 3 recovered fragment sets, Ohio, Texas, Germany, are now the most important rocks on Earth from a scientific standpoint, not because of what they are, but because of what they imply. If the Vestoid connection holds under further analysis, if additional events in the coming months continue to show HED mineralogy, and if the radiant distribution continues to point back toward the Anthelion region geometry, then the stream hypothesis gains traction. Researchers will be able to back-calculate a rough orbital solution. The parent body search can begin in earnest. The structure of what Earth is moving through can start to be mapped. This is exactly how meteor shower science has always worked. You build the model from the impact record, and then you go looking for the source. But that process takes time, and time is the variable whose value we don't currently know. The uncertainty here is not a media failing. The science genuinely hasn't resolved this yet. The AMS analysis, published in early April 2026, acknowledged the anomaly, documented the statistics, and flagged the Anthelion and high declination concentrations as significant. It did not claim a debris stream. It did not name a parent body. It said, in the careful language of responsible science, that the pattern was unusual, that conventional explanations were insufficient, and that further monitoring was required. That is the honest state of the knowledge. Further monitoring means more time. And while more time passes, more of whatever is behind this arrives. So here is where we are. There is a documented statistical anomaly in the fireball record, 4.5 standard deviations above the expected rate for large, energetic events. There is a mineral signature linking multiple unconnected events to a single asteroid family. There is no identified parent body, no named stream, no orbital model that currently explains the full pattern. There are competing hypotheses, none of which fully accounts for all the variables. And there is a set of physics principles, well established and not in dispute, that describe exactly how a debris stream delivers its contents over time. Smallest first, largest last, the leading edge preceding the core by years, decades, or centuries, depending on the stream's age and internal structure. Every meteor shower you've ever watched is the legacy of a catastrophic event. A comet fragmentation, an asteroid collision, a planetary encounter that ripped material free and flung it into shared space. The Perseids exist because Comet Swift-Tuttle sheds its outer layers on every orbit. The Leonids explode in intensity every 33 years because the stream has a dense core that Earth periodically passes through. The Quadrantids trace back to a body that may no longer exist as an intact object, a comet or asteroid that broke apart and left only its stream as evidence of its former mass. Every stream is a ghost story, a record of destruction. And every time Earth moves through one, it reads a chapter of that story in light and sound, and occasionally in rocks through the roof. What we may be reading right now is the opening line of a chapter whose full length is not yet known. The physics says the small pieces come first. History says the stream has a source, and science says the source is still out there, somewhere between the current impact record and the empty space where a parent body has not yet been identified. What comes first in a debris stream is the smallest pieces. What comes last is the thing that made them. And in every known case, the first thing you see is the smallest fragments. The last thing you understand is what they broke off from. We're still in the first part of that sentence. The data is telling us something. The question is whether we're asking it the right questions before the second part arrives.